Once all of your individual tests have been defined, you can combine those tests into one test sequence for automation. If you have just one or two devices, you can load each test one by one and run them interactively, but then you will have separate log files for every test. If you want all the data in one log file, you would have to combine the files by hand. You also would have to remember the sequence in which you want those tests run, as well as track where you are on the list. All of this can be automated in batch testing. With batch mode, you define the sequence of tests, and all of the results can be saved in one log file. If you have multiple devices to test, one lot for example, you can save all the results for the entire test run in the same log file. Let's look at how we create a batch test. When you start, the list will be empty. You can use the plus button to add tests to the list, or use the minus button to remove a test. The up-down arrows are used to modify the test sequence. Tests are always executed from top to bottom on the list. Typically, you may start with a continuity test. That might be followed by a curve trace with one set of conditions, and then maybe a pin-to-pin connect test. You may want to run another curve trace with different parameters, or a different set of pins, and so on. For example, if testing a system on a chip type of device, you may have a different set of tests for each subsystem of the device. You define the complete test flow, and you can save this for execution in the future. When you are satisfied with your list, hit the Start button to begin execution of the tests. If you'd like to run just one of the tests on the list, just highlight the test and click the Run Selected Test button. As the test is running, you will see progress displayed in the log area of the panel. When it has finished, you can open the log file to view the results. Clicking the plus button will open a new window for adding a test to the list. Here you can browse for your saved test setup file. Remember that all test definitions are saved in your setup file, such as curve trace parameters, continuity test, and pin-to-pin connect test. Here you select which type of test will be executed. You can run different types of tests from one setup file. Test name is used to put some short description of the test. It will appear in the log file and is there for your convenience, but a test name is not required by the software. When you click OK, this test is added to the list. Here is the batch mode setup file. As you can see, the structure is very simple. It starts with a keyword identifying it as a batch list file. This is followed by the list of tests with the type of test and the setup file used. The file is closed with another keyword. One very important point is that the path to your files here is relative. The batch mode setup file and all of your supporting files must be in the same folder. So when you want to move the test to another folder, be sure to include all of the files needed. When you start the test, you will see the progress. You see the tests already executed, the test currently being executed, results for those tests, and the runtime for each individual test. This information is displayed next to each test as they are running, and is also shown in the log window. Once the test is done, you click Open to view the results, and browse the log file to see details about each individual pin in every test. Here is an example of a results file. Again, the first line is a keyword identifying the file with date and time as well. Then we have a description of the test type and the setup file name. You see the global results, and then the measurement for each pin individually. Scrolling down, we have results for a curve trace. But how do we know this test actually passed? We know because for this test, we defined a golden pin file. In batch mode, we first run a curve trace, then compare the results to those of a golden device using the golden pin file. If the results are within the accepted variance, it will pass. If it's outside the variance, it will fail. This concludes the theoretical training videos. Please move on to the practical training video series for the high-level CurveMaster curve tracer.